So in this video, we're going to be looking at rubber duck debugging. And of course, to start off, what you need to do is you need to get yourself a duck and you need to name your duck. Once you've got your duck, we can then start thinking about debugging. So this is all about finding errors in computer programs, understanding, we're going to look at the difference between syntax, the different types of errors, syntax, runtime, and logic. We're going to try and then use a rubber duck to help us debug our code. And you might think, well, how are we going to do that? You just need to wait and you'll find out. Now, as it says here, rubber ducks aren't very good at programming, but as it says, yeah, they might look as though they want to learn. And if you go into any work office where you've got a lot of software developers hanging around, you quite often find a lot of rubber ducks, and you might think, why on earth would that be? And the answer is because they're using them to help them debug their programs. And as it says here, one of the big things about rubber ducks is they are exceptionally good listeners. So they pay full attention, they never fall asleep, they don't get distracted, they really focus on what's going on. Now, when you're programming, there are three types of errors that you might get. So first of all, we get syntax errors, and they're usually pretty easy to spot because what happens here is you've broken syntax. In other words, you've broken the rules of the language, so the code you've written is invalid, and therefore the programming environment will tell you there's an error here, you need to fix it, I don't understand what this means, and it will not allow the program to run until you fix it. So those will be spotted by the software development environment. We then have runtime errors, and again, these are easy to spot. These happen when you run the program, as the name suggests, and what will happen is your program crashes and you'll get an error message. So an example of this would be if a program attempted to divide a number by 0, it would cause it to crash. If a program tries to open a file that doesn't exist, it would cause the program to crash. And again, you'll get an error and it will tell you what's going on. We then have logic errors, and as it says here, these are the hardest to spot because what's happening here is the program is working, but it's producing the wrong result. And they're incredibly frustrating to deal with. And this is where your rubber duck comes in. So if you look at this piece of code here, we've got this Python statement here. It says name, it's reading a person's name. It's asking the person to enter their name, storing this in a variable called name. And then at the end of that, you might have noticed that we are missing a speech mark at the end. So we've got an open speech mark right at the start of the statement, right here. But there should be one right here to close off the string. This is a text string. And when we have an opening speech mark, we need a closing speech mark. So we're missing a speech mark there. Now, that kind of error, again, would be spotted by the software environment, but it really helps if, as a developer, you can spot these kind of things. And certainly if someone gives you a program and says, my program's not working, please help me fix it, being able to spot these things is a really important skill. And it's an important skill in being a computer programmer. So if we look about this line of code here at the bottom, down here, we're looking at trying to identify what the problem is there. So just spend a moment or two looking at that and try and work out what is missing. And you might have noticed that if you count up the number of brackets, we've got two opening parentheses. We've got this one right here. We've got this one right here, but we've only got one closing parenthesis. So that means that we're missing a bracket at the end, and we need to correct that by adding this extra bracket right here. Now, when you get runtime errors, like you might get a runtime error caused by this piece of program code here. And what happens is the error gets displayed on the screen, and you might look at that and think, well, that's a bit meaningless to me. But it is actually telling you what's going on. And the question here is what's happening, what went wrong. And as I said, the environment is telling us what's going wrong. So here we can see the line in blue, this one right here. It says enter a number. Well, we can see that comes from this command line here, enter a number. We can then see in our code it then took answer and it tried to set the variable answer equal to the number, which is what the person just typed in, and it's dividing it by 2, and it's generated some kind of an error there. And you can see down here it's saying that on line 2 we've got an error, and it's telling us the line 2 code is this line right here, so it's showing you the piece of code that's gone wrong. And then down here, you're getting this error message coming out, and it's telling you what is happening. And if you look here, it says unsupported operand types for divide, and it's saying string and integer. Now, if you know about maths, what you should know is that when you write a maths expression, for example, 5 divided by 3, the 5 and the 3, the correct name for those is operands. This thing in the middle, the division symbol, that is a maths operator, mathematical operator. So knowing that, we can see that it's telling us that we've got the operand types are wrong. We've got a string and we've got an integer. So if we look at the line of code here, this division, which is line number 2 here, it says answer is num divided by 2. Now, if we look at line number 1, the one at the top right here, we can see num equals input, enter a number. Well, what we need to remember is that whenever you type anything in, whenever a user types anything in, what they're entering into the computer is text. And therefore, what Python does when it allocates the variable called num is it creates a text variable, a string. So that means num, despite being called num, is actually a string. And then it's saying take a string and divide it by 2. Now you can't do that, and that's what's causing the error. So if I just get rid of all those marks on the screen now, we've saved the number, we've saved the user entry as a string variable, and therefore the error message tells us that you can't have that. We've got a string and an integer, and we need 2 integers or 2 numbers to float. Now the way we fix that is what we do is when the user enters the value, what we're going to do, and you can see this again right here, is we're using the int function with an open and a closed bracket. And what this will do is it will take whatever's between those brackets and it will turn it into an integer. And then that means that when Python allocates the variable here, it'll be an integer variable, and therefore we can divide it by 2, and the code will work as required. Now, logic errors might happen like this. So this is an example of a logic error. There's nothing syntactically wrong with that code. That code there meets all of the requirements for Python, the programming language. Also, there aren't any errors in that code which will cause it to fail at runtime. That code will work. Problem is, it produces the wrong result, because when the user enters, it says, you notice it's saying when the number is when the user enters the number 4, it says too high, but when they enter 20, it says thank you. So we've got to think, well, what's going on here? And we need to spend a moment or two looking at the code. And when you look at the code, you might spot that the comparison in the middle here saying num is less than or equal to 10. That seems to be, that looks to be wrong. Now we can fix this in one of 2 ways. What we can do is we can change the the comparison operator from less than equal to greater than equal to, and then when we enter a number that's bigger than 10, the computer will tell us too high, rather than saying when the number's less than 10, it says too high. The other thing we could have done is we could have swapped the items around. So we could have taken the line that says too high and swap it with the line that says thank you, and then that would have achieved exactly the same result. There's 2 ways of fixing that error there. Now, how does the rubber duck come out? Well, what happens is when you've got code that's causing you a problem, as it says here, what you want to do is talk to your duck and describe what's the error message. Well, in this case, we're going to talk to the duck and describe an error message. So logic error, we might have misspelled a word. We might have missed out a colon. Sorry, a syntax error. We might have misspelled a word. We might have missed out a bracket. The colon might be missing after an if statement. There's all sorts of errors that will happen like that, but the key ones you want to look for are misspelt words, missing symbols, so like an unbalanced bracket or unbalanced speech marks. So for a runtime error, an example of those would be divide by 0. And a logic error, the program's put the lines of code in the wrong order is one example, or the program is trying to divide, say, a number by, or a string by a number. The programmer is trying to multiply 2 strings together, those kind of things. Now, how does the duck help? Well, the duck helps because, as you can see, we've got this computer here and there's a duck on it. And as it says here, as humans, we think faster when we talk. And by talking, what happens? You slow down your thoughts, and then you're more likely to see what the problem is. And those of you that are thinking ahead might think, well, I can see what's going to happen here. So as it says here, programmers often find it helpful to talk through a problem. Now, that means if you're a programmer and you talk through your problem, they find it helps them fix the problem. And you actually might notice that this is what teachers spend a lot of time doing. When you have a problem and the teacher comes over and helps you out, a lot of the time, all they're really doing is just talking through the problem with you or getting you to talk through the problem. Now, a lot of programmers, as we say, have these ducks because what they do is they talk to the duck and it just helps them think about what is really happening with the program. So the process you follow when you do rubber duck debugging is, what we do is we take our code and we explain to the duck what the code is supposed to do, line by line, and then we explain to the duck what the code is doing. So here's a program, and what you're going to do for this task is you're going to go to this, use this link here to open the program in Replit. When you're in Replit, if you try and run it, it won't work because it's got some errors in it. And what you need to do, or the code might well work, but it's got some errors in it and you need to fix it. So what you're going to do is you're going to talk to your duck. So if you haven't got a duck, you could maybe, I don't know, get an orange or something. It doesn't matter what it is. So just talk to the orange, talk to the duck, talk to the lampshade, whatever it is you want to talk to, and just say, okay, on line 1, it's asking me to enter a number. And then on line 2, it's asking me to enter another number. And it's turning that into an integer. And it's storing that in a variable called number2. And then on line 3, it's saying that if number 1 is bigger than nums, a variable called nums, then line 4 says it's going to print num1 is bigger than num2, and so on. So you talk the code through line by line, and then once you've done that, you want to think, well, what is it asking me to do here? What is the code trying to do? And we can see on line 1 it's asking me to enter a number, and on line 2 it's asking me to enter a number, but straight away I can see there's a difference here, this thing here. So I think, well, what does that mean? And that's got me thinking about whether or not I need to use that expression on line number 1. So this process can be really, really useful. Now, once you've done that, I'd like you to have a go at task number 2 here. And in task number 2, we've got a program called Number Guess, which you can find on this place on Replit. You're going to go into this, and here is our computer program. Now, a little few things in case you've forgotten. This statement at the top here is telling Python that we are using a library which is called random. This statement here is using a feature of that random library, and it's called randint. And what that means is produce a random integer in this range. So it produces a random integer between the number 1 and 100 inclusive. And it stores that in a thing called comp_num. So all that's doing is generating a random number between 1 and 100. And then we've got this while loop. So the program's going to run through this code here. And then if the condition is still true, and says while play again is true, it's just going to keep on looping around and around and around, repeating that piece of code over and over and over. And then once that condition becomes false, once play again is not true, so the test is false, it's then going to come to this line of code at the bottom here, and it's going to print you took guesses, turns to get it right. Now again, that program's got some faults in the code. What you need to do is talk to your rubber duck, explain what you want the program to do, and then line by line explain what each line is doing and what it's actually doing rather than what you want it to do. And sooner or later you'll identify, well, I want it to do this, but it's actually doing this other thing, and therefore that will help you find your problem. Now, if you have done task 1 and task 2, it's now time for you to try and do something that's a little bit harder. So this is a little bit more challenging. We have a program called rock, paper, scissors, which is on this, which you'll find on this link in Replit. So there's your link. I'd like you to go over to that link, and then once you've done that, you've got 4 errors there. Now, as it says, we're not going to tell you whether they're syntax errors, runtime errors, logic errors, but there are 4 errors in the program, and your task is to try and work out what the program is supposed to do, and then what each line of code actually does, and identify what those errors are and to fix them. Now, for all of these tasks, what you're going to need to do is produce a document. It should be in Microsoft Word. And what we're going to want is for task 1, what does your final code look like? In task 2, what does your final code look like? And again, in the extension task, if you've attempted that, remember the extension task is an optional extra for those that finished a little bit earlier. But in that extension task, we'd like to see what the code is. What you could do, please remember that we want you to copy the code from Replit and paste it into your Word document. So go into Replit, select all the code, press Ctrl+C, go into Word, click in where you want the code to be placed, and then press Ctrl+V to paste it in. Please don't take screenshots because they're unreadable. But we'd like you to put the code in. If you really want to kind of go to town on it, what you could do is you could use the highlighting feature in Word to highlight the parts of the code that you had to change. So maybe if you had to fix an error, or you could just write a short explanation of what you had to do to fix the problem. Remember, please, there should be a title at the top of the document. I would recommend you use the assignment name for the title. And obviously make sure your document is error-free before you hand it in to your teacher. Now, before we just finish off, we're going to look at how rubber duck debugging, or this kind of approach, can help you. Because rubber duck debugging can help you out in all sorts of other areas. Computer science isn't just about computers. We can use computer science techniques all over the place. And rubber duck debugging is an example of this. So we can use it with any complex problem that you face with. So as it says here, if you've got a maths problem, rubber duck debug it. So start talking through the maths equation problem. So where should we start? What do I want it to do? What is it actually telling me to do? And if there is a discrepancy between those, if there's a difference between them, then you've identified your problem. Again, if you think, how are you going to do an experiment? What do I want to do? And then mechanically, how am I going to do it? And then down here, if you're revising for an exam, as it says here, what you can do is you can explain to the duck things, because explaining helps you remember things.